In this chapter, we're going to talk about functional groups that contain nitrogen. And you're going to see a lot of similarities to the functional groups that we talked about with oxygen. Things like alcohols and esters are going to look very similar to what we're going to see with nitrogen. So let's first talk about the common bonding patterns for nitrogen. And as a refresher, we want to remember carbon will always have 4 bonds. Oxygen we know is 2 bonds and 2 lone pairs. Nitrogen is between those two on the periodic table and has 3 bonds and 1 lone pair. And then just to throw it in, anything from group 7 is going to have 1 bond and 3 lone pairs. So as we add nitrogen to our structures, we want to keep this common bonding pattern in mind. We have 2 functional groups that we're going to focus on with those nitrogens. We have amines and amides. Very small difference in the name, the N versus the D. The biggest structural difference is that the amides do have a carbonyl, whereas amines do not. So for amines, we're going to have nitrogen. It has a lone pair, and it will be bonded to 3 R groups. Those R groups can be the same or different from each other, and they could be hydrogen or sp3 carbon atoms. For amides, you're going to have that carbonyl. That carbonyl carbon is directly attached to the nitrogen that has a lone pair, and then it will have 2 R groups to fill in the 3 bonds. Again, R can be hydrogen or sp3 carbons. So let's just look at a few quick specific examples. Here would be the structure of an amine. We have 2 R groups that are carbons and 1 R group that is a hydrogen. We have the lone pair on nitrogen, and we also want to notice that the carbons that the nitrogen is directly attached to are both sp3. An example of an amide. Here we have the nitrogen with the lone pair. It's attached to the 2 R groups, one of which is a hydrogen, one of which is an sp3 carbon. And then the third bond of nitrogen is that carbonyl carbon, which then, as we're used to seeing, has the double bond to oxygen. So the key difference there and the easiest thing to see is that was that carbonyl there or not.